4.8, dividing polynomials. We're going to look at these four examples. You'll notice that they're all being divided by a monomial, single terms on the bottom. Well, if we have a single term on the top, we're just going to say, wait a minute, can't we think of this as 15 over 3? And 3 goes into 15 5 times, and we have our quotient rule where we can subtract our powers, and we get 10 minus 4 is 6, so 5x to the 6th power. And that's exactly what we want to be thinking here. We don't need to create a new rule. This is just simplifying fractions. They're just giving you a new name for something you've already done. Over here, 42 divided by a negative 3, let's see, 4 plus 2 is 6. The sum of the digits is divisible by 3. Therefore, 3 goes into that negative 14 times. We have a 1 on our a. 3 minus 1 is 2. 5 minus 3 is 2. So a squared b squared with my negative 14. There's my answer. Now, when we have a binomial and a trinomial on the top, don't panic. Think to yourself, wait a minute. You can write this as two separate fractions. Take 2x to the third, put it underneath each term. If I was adding these together, I would, I have common denominators, so just add the tops over our common denominator. Okay, do that in reverse, and now simplify and reduce. So we're going to have 2 goes into 80 40 times. 5 minus 3, that's going to be 2, so that gives me 40x squared. Then we got 6 divided by 2 is 3. 7 minus 3 is 4, so 3x to the 4th, there's my two simplified terms. Here, if there's 3 terms, 1 term on the bottom, we just write 3 fractions. So here, this first term, I can only cancel the x's, so this would be x cubed over the 3. We'll have 15 divided by 3 is 5. X to the third divided by x gives me x squared, 3 minus 1, so 5x squared, minus 2x to the first. So here there's two ways to write this first term. We could have left it as x cubed over the 3, or because there's a 1 in front of my x to the 4th, you can also write it as 1/3 times x cubed. So if they were asking you what is the coefficient on the x cubed term, we would say 1/3. All right, so I want you to think about how simple this was. It's just reducing fractions. A lot of gazintas here, subtraction of powers. All right, so now we're going to take a look at dividing by a binomial. X squared plus 5x plus 6 divided by x plus 3. So what we would do is we would rewrite this in long division form. The x plus 3, it goes on the outside. The x squared plus 5x, it goes on the inside. And then we're going to get ready to go ahead and divide this. Okay, now wait a minute. How am I going to do this? Because I was dividing by one single term before. Now, how do I divide when there's 2 terms on the bottom? How do I work this out? Okay, well, I'm going to warm up my iPad here, and we're just going to work with numbers real quick. Okay, let's say you had the following. You had a 12, and we're going to divide that into, let's say 6,073. How would we divide this? Well, in theory, you would take the outside number and divide it into the first term and say, well, does 12 go into 6? No, it doesn't. Then you look at one more number over. It's now 60. Does 12 go into 60? Yes, it does. 5 times. We put in our 60, we subtract both, we get a 0, we bring down the 7. Does 12 divide into 7? No, it doesn't. However, this time we have to say 12 goes into 7 0 times because we have to hold that place value in the tens place before we can bring down the 3. Well, 12 goes into 73 6 times, that's 72. That's a remainder of 1, so my answer would be 506, and 1/12 would be my answer. So this is what I want you to be thinking about here. Notice we attacked the first term. Whoops, what happened to my 6 there? We're attacking the first term. So let me move my iPad off to my other monitor here. And now we're going to say we want to attack the x squared right here. Well, 3 doesn't go into x squared. Only this x does. So what we're going to do is we're going to go back to this skill right here. Monomial divided by another monomial. One term divided by one term. So we're going to think about getting rid of this x squared, just like we got rid of the 6, then we got rid of the 0, we got rid of the tens place where the 7 was, until we got to a value that was less than 1. So what we're going to do is we're just going to divide leading terms, because we're going to think of this 6 as being in the ones place, 5x is in the tens place, this is in the hundreds place. So we're going to use the one term out in front that has any chance of dividing into x squared. So x squared divided by x is x. Believe it or not, folks, this is all you can divide. That's our entire division process right there. Now this x is x to the first. We are going to line that up above the 5x. Okay? Everybody agree with that? Well, now, just like we put our number 5 out on top, we had to multiply it to everything in the front. Remember, the 5 times 12 gave us 60. Okay, so this x here, it's going to have to be multiplied or distributed to this binomial out front. So x gets multiplied to x, which this should give us the x squared, because that's what we just did right here. We want to cancel this when we subtract. X times the 3 gives me a plus 3x. Now here, strongly recommend we put in 2 minus signs. I've seen a lot of students just put 1 minus sign, they cancel here, but they forget to bring the minus sign and cancel this, so they get an 8x instead of technically 5x minus 3x, a 2x. So for every terms you have out here, if there's 2 terms, you need 2 minus signs. We might divide by 3 terms, then you need 3 minus signs. All right, now we bring down the plus 6. Just like we did earlier, we brought down the 7 and then we brought down the 3. Okay, now we repeat our steps again. Since we canceled out our leading term of x squared, and it is in descending order, we now have a new leading term. That's 2x. So this 2x gets divided by this leading term. That's all you divide is leading terms. 2x divided by x is 2. Well, 2 is a constant. It has to line up above the plus 6 right here. So we'll put in a plus 2 because it's positive. And just like you did with the x and multiplied and distributed to the front, we do the same thing with the 2. 2 times x is 2x. 2 times 3 is 6. Subtract both columns, you get a 0 and a 0. No remainder. So in this polynomial long division, these first terms must always cancel. That is your goal. Until you get to some term that has a degree smaller than the leading term here. So since this is x to the first, the only kind of remainder you can have left over is a constant, because this x term has to cancel. So our final answer is x plus 2. No remainder. All right, so we're off to the next example. 2x squared plus 5x minus 1 divided by 2x minus 1. Take the denominator, put it outside the long division box, take the top, put it on the inside. All my terms are here. X squared, x, and a constant. Ones place, tens place, hundreds place. Who do I divide first? Is my leading terms. 2x squared divided by 2x is x. X goes above the 5x. Multiply that now to the front. So x times 2x has to be this 2x squared. That's a given. And x times a minus 1 is a minus 1x. It's a given because we divided this right here. We divide, you multiply, you should come right back to where you started. Subtract both columns. Guaranteed this leading term cancels. 5x minus a negative, two minus signs, so that's going to become plus plus. That's a 6x. Bring down the minus 1. Repeat that sequence. New leading term is 6x. Divided by this 2x out front. That gives me a 3. Put the 3 as the constant up above the minus 1 as a plus 3. Multiplied to the front. 3 times 2x has to be the same. 6x right here. That's a given. 3 times minus 1 is a minus 3. Subtract, subtract. Cancels. Whoops. Negative 1. Minus a negative. Plus, plus. We get a positive 2. We have a remainder. So how do we write our remainder? It's going to be plus the 2 over what we divided by. So when we had that mixed fraction earlier, 506 and 1/12, that's the same as saying 506 plus 1 over 12. It's the same thing. But because they're both numbers, we can add this together. There's really nothing to add. We just write it as a mixed fraction. Okay, next example. Now in this case here, we have a special situation. It's x cubed plus 1 divided by x plus 1. Here's what I'm dividing by. It goes outside. But notice on the inside, I start with an x cubed, but there's no x squared term and no x to the first term here. Every term must be represented in descending order. So if I start with x cubed, there better be an x squared, an x to the first, and a constant. Whichever terms are missing, we'll put a 0 in front of the x squared and the x. We need this to line up your like terms when we put them on top of the long division box. So let's get started. We'll divide our leading terms. X cubed divided by x is x squared. See, if I didn't put my x squared here, I'd be trying to figure out, where do I put my x squared? I can't put it over x cubed, and I can't put it over a 1. There's no like term. We need that x squared there to hold that place value. Just like when we did the division with the numbers, we put a 0 above that 7 to hold that tens place. So the same thing happens with polynomial division. The terms must be there in descending order. So let's multiply our x squared to x and 1. We'll get x cubed plus 1x squared. Minus minus, x cubes are gone. 0 minus 1, negative 1x squared. Repeat the process. Bring down the 0x and bring down the 1. I just like to bring everything down each time. All right, divide your new leading terms. Negative 1x squared divided by x. Negative 1x. Put that above the 0x minus 1x. Distribute that minus 1x to the front. We're going to get a minus 1x squared and a minus 1x. And we line them up, then subtract them. Remember, these have to cancel. Minus minus makes this a plus plus, plus plus. These cancel out. 0 plus 1 is 1x. Bring down the plus 1. Well, new leading term, x. With this x, x divided by x is 1. Put the plus 1 up here. 1 times x plus 1 is the same thing that's out in front. X plus 1 cancels out to a 0. And there is my answer. X squared minus x plus 1, which now tells us that x plus 1 is a factor of this. So you could technically write this as the trinomial x squared minus x plus 1 times the binomial x plus 1. just like we saw with that first problem when we got a remainder of 0, you can take that answer, which I think was x plus 2, and multiply to what you were dividing by, and that's how it factors. Okay, next example. All right, we have x to the fourth, I'm missing an x cubed, x squared, x to the first, 3, divided by x squared, wait a minute, no x to the first. So we're going to have to install a 0x between x squared and the minus 5, and a 0x cubed between the x to the fourth and the minus 3x squared. 4, 3, 2, 1, 0. 2, 1, 0. Everybody's there. All right, we're ready to divide. Divide leading terms. X to the fourth divided by x squared is x squared. Put the x squared above your minus 3x squared. So now we're going to have 3 columns. X squared has to be multiplied to all 3 terms. And we know we're going to get a 0 here every time, but that's okay. X squared times x squared is x to the fourth. X squared times 0x is 0x cubed. X squared times minus 5 is minus 5x squared. It's okay, now that we subtract, we get lucky here. Not only we cancel the first terms, but we can also cancel the 0x cubed terms. So that's going to save us some time. Here we have minus and negative, so plus plus. Negative 3 plus 5 is 2x squared. All right, bring everything else down. Plus 4x minus 3. Divide by the new leading term, 2x squared divided by x squared. That's a 2. We put the 2 above the constant. Now, could you put a plus 0x here? Yes. Do I need it? No. Multiply the 2 to everything out front. We're going to get 2x squared plus 0x minus 10. Subtract all 3 columns. Again, this first one has to cancel. That's 0x squared. 4x minus 0x is 4x. Plus plus, negative 3 plus the 10 is 7. So notice that the highest degree down here is x to the first, but what we're divided by was a degree of 2. So technically we now have a remainder, which is a smaller degree for this polynomial than what we divided by, and that's your goal. So my final answer is x squared plus the 2 plus 4x plus 7 over what I divided by x squared minus 5. Now, just a note that sometimes these numbers down here might be negative. My philosophy is this. It's always a plus sign, and whatever you have in your remainder, whatever signs are here, put those in the numerator. Do not try to simplify it. Keep it simple. Don't do something extra where you would make a mistake with a sign. Okay? And that wraps up 4.8.